Okay, good. So let's have a look at our sin, cos, tan. Now, as I said previously, the sin, cos, tan, these are trigonometric functions that allow us to find sides or angles in right-angle triangles. And the key to this is figuring out, what trig function that we're going to use. Now, depending on two sides that we're dealing with in the right-angle triangle will determine, what trig function that we use. So the first thing that I'm going to do is, I'm going to talk about the right-angle triangle and the three sides. Okay, so the three sides of our right-angle triangle are known as our hypotenuse, our opposite, and our adjacent. Right? So three sides of the right-angle triangle are known as the hypotenuse, the opposite, and adjacent. And we need to be able to determine which is the hypotenuse, which is the opposite, and which is the adjacent. So the hypotenuse is always opposite the right angle. So there's the right angle there. The hypotenuse is always the longest side. So we have the hypotenuse there. Okay. Now let's just assume that in the exam, the examiner asks us to find this angle. He asks us to find angle A. If he asks us to find angle A, this side here is clearly opposite that angle. So we'll label that as the opposite. And then the third and final side is known as the adjacent. So we'll write that as ADJ. Right? Now you must do that for every question that we're doing based on sin, cos, tan. Always figure out your three sides, because the two sides that you're dealing with will determine what trig function you use. Now, if I take almost an identical right angle triangle, so let me just write it like that, right? Draw it like that. So it's almost identical right angle triangle. There's our right angle, right? Now, the hypotenuse is the easiest one, so we'll call it the hypotenuse because it's clearly opposite the right angle. It's the longest side. And let's say the examiner says find angle A. Now, if we're asked to find angle A now, if angle A is there, this side here is the opposite. And then this here will be the adjacent. So just be careful with it and always label your sides and figure out what two sides are we dealing with, because the two sides that you're dealing with will determine whether we use the sine function, cosine function, or tan function. Okay? Now, how do we remember which one to use, or what will help us to figure out which one to use? We are going to use sa, ka, da. Okay, now there's loads of different ones, right? Just like silly old Harry caught a herring trawling off America, but I think this is probably the easiest ones because it kind of rolls off the tongue, right? Once you say it a few times, it rolls off the tongue. Now, what is it telling us? It's basically saying that sine is equal to the opposite over the hypotenuse, right? So the sine function is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. So just look at the letter. O, opposite. H, hypotenuse. A, adjacent. H, hypotenuse. And then tan is equal to opposite over adjacent. O, opposite. A, adjacent. And that's how we use our SOHCAHTOA. So if you're only dealing with the opposite and the hypotenuse, it must be sine. If we're only dealing with adjacent and hypotenuse, it has to be cosine. If we're only dealing with opposite and adjacent, it must be tan. And that's how we're going to apply our SOHCAHTOA to these questions. But use your strategy. Remember, what was the strategy? Oh, it's a right angle triangle. That's one. Two, ask yourself, is it Pythagoras or is it sin cos tan? If it's not Pythagoras, it's sin cos tan. First thing that we do with sin cos tan is we label the sides. Then we'll write our SOHCAHTOA. And then the rest of it's quite easy. Right? It's just a little bit of calculation work. So that's the approach that we'll always use when we're working on the trig functions. And that's a little bit of information on that on page 8. But let's use our strategy. Now, the one thing I'd say is, just quickly, if the examiner is asking us to find the angle, I always say to lads, make sure you get the shift. Alright, so make sure you get the shift. So on your Casio calculator, you will see a shift button, so you have to press shift, then sine, shift, then cos, shift, then tan. So we're looking for the angle, you get the shift, lads. Don't even know if you know what that means, but it was an old term that country people used to use when they went to coppers. But anyway, you have to get the shift if you have a Casio calculator. So all that information is on page 9. It's fairly straightforward. We're going to apply it when we start doing questions. And on the top of page 10, please, really important, at junior cycle, that your calculator is in what we call degree mode. It must be in degree mode. So you'll either see a little D at the top of your calculator screen, or you'll see a DEG. But that's what you're looking for. If it's not in that mode, you're not going to get the right answer. So there's just little tips that we need to use to make sure that we get the right answer in the exam. Okay? Right, with that in mind, let's have a look at a couple of questions. the questions that we'll do will really kind of just tie this all in. And that's what we're trying to do. So on the bottom of page 10, we're looking at example 1. Right? Now example 1, it says find the measure of the angle x. So if we were doing this fairly straightforward, that's 2, that's 1, and we're looking to find x there. And you can clearly see it's right angled. So I'd be instantly, like straight away, I'd be like, it's right angled. If it's right angled, it has to be trigonometry. If it's trigonometry, it's either Pythagoras or sin cos tan. Could I use Pythagoras to find angles? No, because we only use Pythagoras to find sides, so it must be sin cos tan. But what's the first thing that we're always going to do with sin cos tan? We're going to label our sides. If we're labeling our sides, that's probably the easiest one, the 2. What's 2? 2 is the hypotenuse. Lovely. Like, that's the angle that we're looking for. That side there is clearly opposite. And the final side is the adjacent. So, what trig function are we going to use? Are we going to use sin, cos, or tan? Well, look at the 2 sides that we have information on. What are the 2 sides that we have information on? We clearly know what the opposite is, and we also know what the hypotenuse is. So we've got the opposite, and we have the hypotenuse. Now, what is O and H? So come back to Sakatawa. Right? Where is O and H? Well, O and H is there. So what function are we going to use? We're going to use the sine function. So sine of the angle, sin x, that's the angle, equals what? What's sine equal to? Opposite over hypotenuse. What is the opposite? It is 1. And what is the hypotenuse? It's 2. Now remember, we're looking for that there. What is that? That is an angle. So if we're looking for an angle, what do we have to get? We have to get the shift. So you're going to press shift, sin, and when you do that, you get your sin inverse. So it will look like that in your calculator. Right? So check it out now. Just pause the video if you have to. Go shift sin. It'll be sin to the power of -1. And then you'll press your fraction key in your calculator. And in the fraction key in your calculator, you'll put in 1 over 2. And then you'll press equals, and that is equal to 20 degrees. And that is the approach that we're going to do to this sin cos tan. These trigonometric functions or trig ratios, whatever one you want to call it. So very straightforward, but it's quite strategic. It's like step 1, step 2, step 3, step 4. That's what we're going to try to do each time. Because if we can do that, we can apply that to any question. Even if the question gets a little bit more difficult, we apply the same strategy to the actual question. All right? Right, so that was on page 10. And if you have a look at maybe page 11, and we'll have a look at example 2. And example 2, we're asked to find the angle BAC. Okay, so we're asked to find the angle BAC. So I'll just write out the actual triangle just to make sure you can see it. Right, so there's our right angle triangle. There's our right angle. That's B, that's A, and that's C. All right. Now we're asked to find BAC. So we identify where BAC is. So all you've got to do is just call out BAC to find out where the actual angle is. So BAC. So we're looking for that angle there. Right, so BAC. So just call it out BAC. If we're looking for an angle BAC, it's always the middle letter. Okay? So the middle letter is where the angle is. So it's that A there. Now, we're also told that A to B is root 3, and we're told that B to C is 1. So we're asked to find an angle in a right angle triangle, but instantly, like right angle triangle, what type of question is it? It's trigonometry. If it's trigonometry, it's either Pythagoras or sin cos tan. Now, can we use Pythagoras to find angles? We can't. So we've got to use what? We've got to use sin cos tan. I said to you, the first thing that you'll always do when you're using sin cos tan is what? We'll write down our sides. Now, what are our sides? Hypotenuse, opposite, and adjacent. So let's go and write that. Hypotenuse is always the longest side, so A to C must be the hypotenuse. Lovely. Now, we're looking for that angle. Right, so that's the angle that we're looking for. So that side there, 1, is clearly the opposite. And then finally, the third side is the adjacent. Now remember, depending on the 2 sides that you're dealing with here in your right angle triangle will determine whether you use sin, cos, or tan. So I'm asking you, what 2 sides are we dealing with here? What 2 sides do we have information on? Well, we've got information on the opposite and on the adjacent. So we've got opposite and adjacent. What I'll do is I'll just write Sakatara. Stop. Ka. And look, we're dealing with the opposite, and we're dealing with the adjacent. We're dealing with the O and the A. And which one is O and A? Is it sine? No. Is it cosine? No. Is it tan? It is. So tan of the angle, I'll just write it as theta. Tan theta equals the opposite over the adjacent. The opposite is 1, and the adjacent is root 3. Now we've just got really one more step to go. What are we looking for? We're looking for an angle. What do you got to get? You got to get the shift. So tan inverse. And then you'll use your fraction key in your calculator. 1 over root 3. Put that into your calculator, and that's equal to 30 degrees. If you're not getting 30 degrees, I would say you don't have it in degree mode. Right? So make sure you see that T at the top of your calculator. Right? Really important that you see that. If you're not getting 30 degrees there, you've done something wrong. Alright? And you've just got to make sure that it is on degree mode. And if you go back to pages, on page 10, you'll see how to put it in degree mode. It's very, very, very straightforward. Okay? Right, on the bottom of page 11 then we've got another example. Let's have a look at page 12, and we'll go through example 4 and example 5. Now, in example 4, it's an interesting question, and there was a question like this in 2016, very similar to this in the 2016 exam. So it says, calculate the measure of the angle B correct to the nearest degree. So, this is what we have. Right, so we've got that right angle triangle, that there's the right angle, that's B, and we're told that this is 9, this is 40, and this here is 40. Okay, so, do we have a strategy? We do. What's the first thing you notice? It's right angled. If it's a right angle triangle, what type of questions are going to be? It's going to be trigonometry. If it's trigonometry, it's going to be Pythagoras or sin cos tan. Can we use Pythagoras to find angles? We can't. But we can use sin cos tan. What's the first thing that we always do with sin cos tan? We label our sides. What are our 3 sides? Hypotenuse, opposite, and adjacent. Always is the steps that you'll go through. So what's the hypotenuse? The longest side, so it has to be 41. So there's the hypotenuse. If we're looking to find that angle B, that 40 is clearly opposite. And then this here is the adjacent. Now remember, depending on the 2 sides that we're dealing with, or 2 sides that we have information on, will determine whether we use sin cos tan. In this question here, if I can just go to this question, in this one here, we had to use tan because we only had opposite and adjacent. So we had to use tan. In this question here, we had to use sine because we had the opposite and the hypotenuse. But in this question here, we have the 3 sides. And if we have the 3 sides, we could use either sin, cos, or tan. So what would sin B be equal to? Well, what is the trigonometric function of sine? It's opposite over hypotenuse. There it is there, opposite over hypotenuse. What is the opposite? It's 40. What's the hypotenuse? 41. So that's 40 over 41. What's the trigonometric function of cos? Well, that's ca. Adjacent over hypotenuse. And what's the adjacent? The adjacent is 9. And what's the hypotenuse? 41. And then tan, the trigonometric function of tan is opposite over adjacent. So that's 40 over 9. Now with each of those, we're looking for an angle, so you got to get your shift again, lads. Now if you're getting your shift, it's going to be shift sin 40 over 41, which is 77 degrees. Or if it's cos B, 9 over 41, it's also 77 degrees. And in tan 40 over 9, it's also 77 degrees. So it's a really interesting question. And it really shows how these trig functions work. And if you have all the sides, you can use any of the trig functions, but you'll always get the same answer. You must do. That must be the same angle, regardless of what trig function that you use. And that just makes sense. There was a question asked a number of years ago, and you were given you were told that you had a right angle triangle. Right, so I'll just talk you through this. The question says, in a right angle triangle, the sides are 7, 24, and 25. So in a right angle triangle, the sides are 7, 24, and 25. Find the size of the smallest possible angle. Right? So I'm going to just tell you that again. In a right angle triangle, the sides are 7, 24, and 25. And it says, find the size of the smallest possible angle. Now the examiner didn't give us the right angle triangle. He didn't actually show us the right angle triangle. So what I would always do is I'd always draw it. Right? I would always draw it. It'd be like quick diagram, right? Quick sketch. Right? And in a quick sketch, this is what you'd have, right? So it's right angled, grand. The sides are 7, 24 and 25, so that would have to be 7, smallest side. This would have to be the longest, 25, and this would have to be 24. Okay? And the examiner says, find the size of the smallest possible angle. I said to you earlier that we need to know our properties of triangles. And if we know our properties of triangles, we know that the smallest angle will be opposite the smallest side. So the examiner was looking for you to find that angle. Now you then go and actually ask yourself, what type of question is it? Well, it's a right angle triangle. And if it's a right angle triangle, it's either what? It's trigonometry, so it's either Pythagoras or sin cos tan. Can we use Pythagoras to find an angle? We can't, but we can use sin cos tan. What's the first thing that we always do with sin cos tan? We always label the sides. So this here is the hypotenuse, this here is the opposite, and this here is the adjacent. And what trig function would you use? Would you use sin, cos, or tan? Well, it's very similar to this one here. The fact that we have the three sides, we could use any of them. If we were using sine, sin x is equal to what? The opposite, which is 7, divided by the hypotenuse, which is 25. You could have used cos, you could have used tan, but the examiner's given us the information to use those trig functions. Didn't matter which one we used because we have the three sides. Okay? So very similar to that one there. Okay, lovely. I'll just do one more. Have a look at example 5. Right? Now I'll just get rid of this here. I'll leave that example 5 because coincidentally it's example 5 but it within sin cos tan. Okay, so example 5, what must we do? The question says, find x correct to one decimal place. Now the reason why I want to do this is because you can clearly see that within this question, x is a side, right? It's not an actual angle. So we're told that this is 17, we're told that this is x, this is our right angle, and this is our 30. Now often within the classes, I'll tell you that, you know, trigonometry, when you think of trigonometry, think of like three pieces of information to find the fourth piece of information. So if you look at here, we've got 1, 2, 3 to find the fourth. We've got 1, 2, 3 to find the fourth. That's really what we're looking at. Now here we're looking to find a side. So you go through your strategy and you say to yourself, right, it is a right angle triangle, so it must be trigonometry. Now if it's trigonometry, it's either Pythagoras or sin cos tan. Could we use Pythagoras to find x? Do we have enough information to find x? We only have one side, and it's not isosceles, so we can't use Pythagoras. Right? We don't have enough information to use Pythagoras. So we're going to try to use sin cos tan. Now if we're using sin cos tan, what do we always do? We'll always go and label our sides. So let's go and label our sides. This here must be the hypotenuse. Lovely. That's the angle that the examiner is giving us. So this here has to be the opposite. And then finally, this here is the adjacent. Now remember, depending on the two sides that we're working with, will determine what trig function that we use. So, what are we working with? Well, we want to find the adjacent, right? We want to find x. I need to be clear on this. We want to find the adjacent, we want to find x, and we're told what the opposite is. So we're working with the adjacent and the opposite. So if we had to, we'll restock it all. And again, which one is the opposite and the adjacent? Oh, in the end, well, it's not sine, it's not cosine, and it is tan. So now we're going to write tan of the angle. So we're actually given the angle here. The angle is 30 degrees. So tan 30 is equal to what? Tan 30 is equal to O over A, the opposite over the adjacent. The opposite is 17, and the adjacent is x. So we're not looking for an angle here, we're looking for the side. So this x needs to be isolated. You need to get that x on its own. So just be careful with it, careful when you're changing it about. I would do it in 2 steps. I'd ask myself, I want the x on its own, right? But it's kind of dividing there, so what do I need to do? I need to isolate it, I need to bring it over here. If it's dividing there and we bring it over there, what we're doing, it'll be multiplying. So x multiplied by tan 30 equals 17. Now remember, we need to isolate x. We want that x on its own. But what is x and tan 30 doing there together? They're multiplying. So if we bring over tan 30, what will be doing? It'll be dividing. So x is equal to 17 divided by tan 30. And then all you've got to do is just put that into your calculator. Right? So put that into your calculator, 17 divided by 1030, and that's equal to 29.4. And think, are we dealing with meters? Doesn't actually say, so we can put in 29.4. Do we need to get the shift here? We don't. Why do we not need to get the shift? Because we're not looking for an angle. Alright, so we only get the shift when we're looking for the angle. Alright? Lovely. And that's sin cos tan. Now there's a couple more questions there on page 13. You can have a look at it yourself. It's about Leinster's stance. Fairly straightforward. Just have a look at it yourself. We're going to bring them all together when we answer a couple of exam questions before we finish up the video. Now on page 14 we've got minutes. Very straightforward. I'm not even going to do it with you. I'm going to rely on you having a look at yourself. All you're doing is using your degrees, minute and seconds button on your calculator. That's all you've got to do. Right? So in your calculator you'll see this, your DMS button, degrees, minutes, seconds. Now just be careful, because on the Sharp the button is DMS, but on the Casio it looks like this. Right? So that's your degrees, minute and seconds button. Right? So it looks like that. That is the button in your actual Casio calculator. But that's all you're using. So the question says, change 50.27 degrees to the nearest minute. All you've got to do is put in 50.27 and then press that button. Right? That's it. Right? That's all you're doing. Check it out. Make sure you can do it. It was asked in 2016. That's on page 14 and on page 15. Okay. Now, on page 16 then, we've got angles of elevation and angles of depression. Now, the angles of elevation and angles of depression are actually going back to using sin cos tan. Okay? They're actually going back to using this whole concept of SOHCAHTOA, these trig functions. So don't get too bogged down angles of elevation and angles of depression. An angle of elevation is the angle that your line of vision will make with the horizontal when you look up. Right? So the angle of elevation is the angle that your line of vision makes with the horizontal. That's the horizontal when you look up, so that would be the angle of elevation. Angle of depression then is almost the opposite. When people are depressed, what do? They look down. A lot of people were depressed during COVID, right? Everyone's looking down. So it's the angle that your line of vision makes with the horizontal when you look down. But ultimately all we're doing is we're using it to create right angle triangles. That's what we're doing. So if this was your eye, right, that's the horizontal, you look up, there's your angle of elevation, and there's your right angle triangle. So really, that's all we're doing. Right? We're creating these right angle triangles. And this was asked in 2018, it was also asked in 2015, but the examiner will just give you the diagram and you can clearly see it's a right angle triangle. If he doesn't give you the diagram, I would give you the tip to make sure you go and draw it. So we'll do one of these questions, right? We'll do one or two of these questions. If you look at page 17, example 1 says, a boat is anchored off the coast near 100 metre high cliffs in County Kerry. The angle of elevation from the boat to the cliff top is 15 degrees. The next day the boat moves further towards land and anchors again. This time the angle of elevation is 38 degrees. How far did the boat move? Give your answer correct to the nearest metre and make assumptions as necessary, stating them clearly. So, if I just get rid of this, there's no diagram there, so we definitely need one. A diagram will always help, right? So if we don't have a diagram, like in this one, when the examiner asked a couple of years ago, didn't give you a diagram, didn't give you the triangle, draw it. It certainly helps, okay? So if I read the question again, it says, a boat is anchored off the coast near 100 metre high cliffs in County Kerry. Now, I'm going to draw, my boats are shit, alright? Sorry, my boats are bad. So here's my boat. Right, so there's a boat. And that's anchored off the coast near 100 metres high cliffs in County Kerry. So it's anchored, and then here's the cliffs. Right, I'll just straighten them up. And the cliffs are 100 metre high. Right, so that's 100 metres. And it says the angle of elevation from the boat to the cliff top is 15 degrees. So the angle of elevation is there, that's 15 degrees. Okay, so it's 15 degrees. And it says the next day the boat moves further towards land and anchors again. So here's the boat, and the boat sails closer to land, and when it sails closer to land, it then stops again. But the angle of elevation will change, and the angle of elevation is 38 degrees. Right, so that's 38 degrees. And it says, how far did the boat move? Give your answer correct to the nearest metre, and make assumptions as necessary, stating them clearly. Now the assumption that we're going to make is that the cliff and the sea are perpendicular to each other. For us to use sin cos tan, we've got to have a right angle triangle. And that's what we're doing there. Now what we're asked to find here is, we're asked to find how far the boat moved. So in other words, we're asked to find this distance. Okay, that distance. Now what is the easiest way to find that distance? The easiest way to find that distance is to find the distance that the boat is from the cliff on day 1 and call that x. So that's x. And then find the distance that the boat is from the cliff on day 2 and call that y. And if we subtract y from x, what do we get? We get the distance that the boat moves. And that's the approach that we're going to use, right? So let's find out the distance that the boat is from the cliff on day 1. And if you had to, you could just do a quick sketch of what's going on. That's 100, that's a right angle, and that there is 15 degrees. And we want to find x here. Right, so it's a right angle triangle, must be trigonometry. It's either Pythagoras or sin cos tan. Can we use Pythagoras? We can't, right? But can we use sin cos tan? We can. How do we use, what do we do in order to use sin cos tan? What's the first thing that we do? We always label our sides. So we'll label our sides. This here is the hypotenuse, this here is the opposite, and then this here is the adjacent. Do it underneath. That there is the adjacent. Now remember, depending on the two sides that we have, will determine what trig function we use. So we have the opposite, and we want to find the adjacent, it's got to be tan. So the tan of the angle, tan 15, is equal to the opposite, which is 100, divided by the adjacent, which is x. Go and rearrange them, and x is equal to 100 divided by tan 15. And that's 373.21 meters. Okay, so 373.21 meters. So that's the distance that the boat is from the cliff on day 1. Now let's find the distance that the boat is from the cliff on day 2. Right, now again, we could do a little sketch. Right, so that's 38. This is y, and that's 100. But it's done exactly the same way. We go through our strategy, we use our trig functions. We're going to call this the hypotenuse, we're going to call this the opposite, and we're going to call y the adjacent. What trig function will we use? Well, it's still tan. So the tan of the angle, tan 38 equals the opposite, which is 100, divided by the adjacent, which is y. Rearrange that, y equals 100 divided by tan 28. No need to get the shift because we're not looking for an angle. Put that into your calculator. Y is equal to 127.99 meters. Now how will we get the distance that the boat moves? Remember, it's x minus y. And x is 373.21 and y is 127.99, so that's equal to 245 meters. Lovely. So the graph, drawing that sketch, or I shouldn't say graph, the sketch, the diagram, it definitely helps. It gives us a greater understanding of what actually is going on here. But even though it's an angle of elevation question, all it really is using sin cos tan. That's what we're doing. Okay? Now maybe we might just have a look at one more of those. Have a look at page 18. So just turn to page 18. Have a little reading question on the top of page 18.